Engineering mechanics by definition is a branch of physical sciences concerned with the state of bodies that are under the action of forces. So mechanics studies the state of bodies. Let's consider a body of mass m, say mass m, under the action of four forces that are of the same magnitude F and acting opposite to each other. So two forces acting along the x-axis of same magnitude F acting opposite to each other. Two forces acting along the y-axis of same magnitude F again, and that two are acting opposite to each other. So in the force system you can see the forces along the x-axis cancel each other and the forces along the y-axis cancel each other. So the net force in the force system is 0. That is a condition for equilibrium of a body, and therefore we can say this body is in an equilibrium state. Now let's assume we remove one force from this system. Now we have only three forces in the system, and these two forces cancel each other, and the resultant force in the body is the force that is acting along the positive y direction. And because there is a resultant force in the body, we can say the body is in a non-equilibrium state, or it is not in an equilibrium. And this is the condition of state that we study in engineering mechanics, condition of equilibrium or non-equilibrium. Going back to the definition, it studies the state of bodies. What kind of bodies that we deal in mechanics? Mechanics can be broadly classified into rigid body mechanics, or deformable body mechanics. A rigid body mechanics is again classified into two, that of statics and dynamics. We mainly concentrate on the rigid body mechanics in these topics. So what is statics and dynamics? Statics deal with the state of bodies that are either at rest or in a uniform velocity motion. Whereas dynamics deals with the condition where there is an accelerated motion in the body. I'm sure you all must have studied the velocity and acceleration in the previous classes. Just to recapitulate your memory, by definition, velocity is the rate of change of distance with respect to time. What is the rate of change here? Or how can you define, how can you understand rate of change? I'm sure this is a term that confuses most of the students. What is the rate of change? Let's consider you start to move from a point, say A, along a straight line. Assume in the first second you cover a distance of 1 meter. In the next second you cover another 1 meter. The third second you cover 1 more meter. And in the fourth second you cover 1 more meter, and so on. So if you consider the first 4 seconds, just for an example, you will cover 4 meter in the first 4 seconds, and you will be 4 meter away from your origin. So in the figure you can see in each second you cover 1 meter. This is the first second, and this is another second, this is another second, this is another second. So in each second you cover 1 meter, and your distance increases by 1 meter from origin. So in the first second it was 1 meter, in the next second you are total 2 meter away from the origin, and in the next second you are 3 meter away from the origin, and so on. So the rate of change in unit time, here it is a second, so the rate of change of distance in unit time is 1 meter here, or in every second your distance changes by 1 meter. So that's it, we defined the rate of change of distance or velocity, and in this case the velocity is 1 meter per second. Now what is acceleration then? By definition, acceleration is a rate of change of velocity with respect to time. Again, let's consider you start to move from a point A along a straight line, and in the first second you cover 1 meter. In the next second you cover 2 meter. Let's make it a bit more clear. In the next second you cover 2 meter, and in the third second you cover 3 meter. So even though the time interval remains same, you are covering different distances here. As you can see, in the first second you cover 1 meter, in the next second you cover 2 meter, in the third second you cover 3 meter. So at the end of the third second you will be 6 meters away from your origin. But here you can see each second the distance you cover it changes. Between the first and second it increased from 1 to 2. Between the second and third it increased from 2 to 3. And the rate of increase is 1. This 1 is increased to 2. 2 is increased to 3. So the rate of increase or rate of change of velocity is 1 here. In each second your velocity is increased by 1 meter. And that's it. We defined acceleration as well. So the rate of change that is happening to velocity is 1 meter here, and therefore in this case the acceleration is 1 meter per second square. You can see how the meter per second turned to meter per second square in acceleration in the subsequent in the following classes. So that's it. We defined mechanics. It's a branch of physical sciences concerned with the state of equilibrium or non-equilibrium of bodies, rigid body mechanics or deformable body mechanics. Rigid body mechanics is again classified into two, that is statics and dynamics. Static deal with rest or uniform velocity motion, and dynamics deal with accelerated motion. So mechanics studies the state of bodies that are under the action of forces. We defined engineering mechanics in the first video. Now, before moving further into the subject, let's try to look into some fundamental concepts which will be very helpful in the further studies. Here in this video, we are going to study the unit system and how it is derived. A unit system is very crucial when you study mechanical engineering, especially when you deal with equations, solve problems, and derive formulas. There are different commonly used system of units, but for convenience, we only deal with one unit system here, and by the end of it, you will be able to switch between unit systems as and when needed. Let's see a very commonly used unit system called System International, or SI system, in which there are three base quantities and a fourth derived quantity. In every unit system, there will be four quantities, three of which are the base quantities, and the fourth one is derived from the first three. They are length, mass, time, and force. These are the base quantities, and the fourth one is derived from the three base quantities. In SI system, the length unit is meter, mass unit is kilogram, time unit is seconds, and force is Newton. Now let's see how we can reach to force from these three fundamental quantities. We already defined the correlation between velocity and acceleration in the previous video, and we know velocity is length over time, and in SI system length unit is meter, time is second, so velocity is meter per second. Acceleration is velocity over time, that is velocity over time, and mass is kilogram kg. And now from Newton's equations we know force is mass into acceleration, that is mass into acceleration, that is kilogram meter per second square or Newton. So 1 Newton is the force required to move 1 kilogram at an acceleration of 1 meter per second square in SI system. Now let's see a different unit system and check between these two. Let's see how imperial system works. In imperial system, the length unit is feet, mass is slug, time is seconds, and force is pound force. So in imperial, as before, force is mass into acceleration, that is slug feet per second square, and that is pound force. So 1 pound force is the force required to move 1 slug at an acceleration of 1 feet per second square in imperial system, which is very similar to Newton, where 1 Newton is the force required to move 1 kilogram at an acceleration of 1 meter per second square. So the difference between imperial and SI system is this is SI system and this is imperial. So kilogram change to slug, meter change to feet, second remains the same. So if you know the conversion between meter to feet and kilogram to slug, you can switch between SI system and imperial system very easily. So this is what I mentioned in the beginning of the video. If you know the relation between the 3 fundamental quantities and the 4th quantity, then you can switch between the unit system very easily. The length, time, and mass are used to derive force. That is same here. Length, time, and mass is used to derive force. So once you get a thorough understanding of the relation between the three fundamental or base quantities and the fourth derived quantity, then you will be able to switch between any unit systems very easily.